In this video, we're going to look at visualizations of graphs and talk more about the connection between increasing and decreasing functions and the first derivative, as well as relative maxes and mins. So consider the graph of f of x that we see to the right. Over which intervals, or which values of x, is the function increasing, and over which intervals is it decreasing? Over which intervals will the derivative be positive, and over which intervals will the derivative of this function be negative? And does f of x have any relative maxes and mins? Does it have any absolute maxes and mins? So I would like you to pause and try this out. We'll talk about it in a moment together. Over which intervals is the function increasing, and over which intervals is it decreasing? So we know that the definition of increasing is that for any a and b over the interval where a is less than b, the output f of a is less than the output f of b. So that's the official definition, but we can also just look at it visually and see that over this entire interval, so up until this point, f of x is increasing up until that moment. Where else is f of x increasing? It's also increasing over here, so f of x is increasing over here as well. And in general, if as we move to the right in x, y is going up, then the function is increasing. Let's write those now as intervals for x. So it's increasing over the intervals from it looks like negative infinity, because it has no starting point that we're aware of, so we assume that the graph just continues doing what it's doing. So from negative infinity up to this point, where is that? Maybe that's negative 1.8 or something, negative 1.8. And it's also increasing over here. Maybe it looks like that starts around 4. So from 4 up to, as far as we're aware, infinity. We're not really sure exactly what's happening with the function after that point, but that's just sort of a guess. So what about where is it decreasing? So it's decreasing from this point forward, and it's also decreasing over here. And then there's this break in the middle at x equals 1 where, the function is neither increasing nor decreasing. It's just not continuous. So where is it decreasing? It's decreasing over the interval from that was like negative 1.8 up to 1, as well as the interval from 1 to 4. So those are the intervals over which the function is increasing and decreasing. All right, over which intervals will the derivative be positive? Over which intervals will the derivative be negative? Well, as we saw before, when the function is increasing, its derivative will be positive because the slope is a positive value. So the slope is going to be positive, the slope of the tangent line to the curve at those points, which is the same thing as the derivative at those points. So we have a derivative f prime of x greater than 0 over those same intervals from negative infinity up to negative 1.8. and from 4 up to infinity. And similarly, we've got negative derivative, f prime of x less than 0 over the intervals we already specified from negative 1.8 up to 1 and from 1 to 4. And notice that at this point, f prime of 1 does not exist because the function is not continuous at that point, and that means the derivative does not exist at that point. Does f of x have any relative maxes and mins? Does it have any absolute maxes and mins? So we do have a relative max right here at that. So relative max at x equals negative 1.8. We can see where that is on the graph. It's the point negative 1.8, comma, let's say 2.4. So that's approximately where that relative max is. And that's all that we see in terms of relative maxes. how about relative mins? Relative mins at, let's see, well, this is a relative min because it is smaller than all of the values around it in an open interval. And so there's a relative min at 1 comma negative 1. And again, note that that's a place where the derivative does not exist. So we know that minimums and maximums can occur at places where the derivative does not exist or where the derivative is equal to 0, critical values. And what else have we got? We've also got a relative min right here, and that's the point 4 comma negative 1. So 4 comma negative 1 is also a relative min. So observe that with these relative mins, it was decreasing and then increasing, or in other words, the first derivative was negative and then the first derivative was positive afterwards. With the relative maxes, the first derivative was increasing and then the first derivative was decreasing. And then we also have this relative min, again, where f prime of 1 does not exist. So those are, so they can also occur at those kind of places where the function is not continuous. All right, one last comment is that this is not a relative or absolute max because this is not filled in. So the function is not defined at 1 comma 4. This is an open circle at that point. Finally, are there any absolute maxes and mins? Well, this is not relative or an absolute max. There are no absolute maxes on this function. Like here, there is no one point that we could say is taller than all of the other points or higher than all of the other points. So no absolute max for this function. And it also looks like no absolute min for this function because it looks like it just continues going down forever. So no absolute min either. All right, now we have a slightly different question. Here is the graph g prime of x. So g prime of x, this is the derivative of g. We're going to use this to answer questions about the original graph g of x. So given the graph of the derivative, over which intervals, which values of x, will the original function g of x be increasing, and over which intervals will g of x be decreasing? And second, does g of x have any relative maxima and minima? So again, pause and try this out. We'll talk about it in a moment. All right, so we saw before that the derivative is negative over an interval exactly when the function, the original function, is decreasing over the interval, and the derivative is positive over an interval exactly when the function is increasing over that same interval. So that was this connection between the positive or negative sign of the derivative and whether the original function was increasing or decreasing. So here we're just looking to see when is the derivative, greater than 0, when is it above the y-axis or above the x-axis, and when is the derivative less than 0, when is it below the x-axis. So we see that the derivative is positive here. The derivative is above the x-axis, and it's also positive over this interval. The derivative is above the x-axis, and it's negative in the almost the complement, except for those specific points where the derivative is 0. So it's negative over those points. So, okay, let's write that down. That means that the original function g of x is increasing over the intervals from negative infinity up to, that looks like maybe negative 2.6 or something, up to negative 2.6. And it's also increasing over the interval, maybe that's 0.5 to 3.7 or something. So 0.5 to 3.7. So it's increasing over those two intervals. And g of x, again, the original function, is decreasing when the derivative is negative. So when is the derivative negative? It's negative over the interval, so it's negative over this interval here, from negative 2.6 up to negative 0.5, and it's also decreasing from it's also decreasing from 3.7 up to infinity, again, when the derivative is negative. Does g of x, the original function, have any relative maxima and minima? So remember that the original function has maxima and minima when the derivative switches from being positive to negative or negative to positive. So these are going to be the points where the derivative switches between positive and negative values, where these relative maxima and minima are going to occur. So yes, and one such value is at x equals negative 2.6. Here, the derivative goes from being positive to being negative. So that means that the original function was going up and then going down. It had a positive derivative and then a negative derivative. So that means that this was a relative max. So we got relative max at the point x equals negative 2.6. What else do we have? We've got, let's see, we're going to have something at this point. So here it went from going down to going up. And so at that point, here at x equals negative 0.5, this would be a relative min. So relative min at x equals negative 0.5. And lastly, at this point, the derivative again went from being a positive value to being a negative value. So the original graph was going up, had a positive slope, and continued having a positive slope, and then has a negative slope at x equals 4. So again, x equals 4 is going to be a relative max. So those are the x values at which we have relative maxes and mins for the original functions based on where the derivative is positive or negative. We don't know the output values. We don't know what g of negative 2.6, etc. is because we don't know what the original function was. We just know there is a relative max at those 2 points and a relative min at that one point.